Welcome to Hyperscale Data Center Mega SOP Part 2. On-time delivery, OSHA compliance, life safety, workforce sustainability, and fiber copper quality. Project Hyperscale Data Center Operations. Applies to TPMs, LVVs, GCs, subcontractors, consultants, QA and QC teams, facility management, client representatives, and validation teams, and network deployment teams. By José-Alonso Hurtado González. Objective: complete projects safely and on schedule by prioritizing OSHA compliance, protecting human life, ensuring quality, and maintaining reliable fiber and copper infrastructure. 10. Quality control and QA and QC integration. 10.1 Required inspection points. Inspections and verification must be performed during pre-installation, post-installation, pre-energization, pre-validation, post-validation, and prior to any reburn or rework activities. 10.2 Core quality requirements. Ensure clean connectors, accurate labeling, proper routing and dressing, bend radius compliance, approved splicing quality, correct port rack designations, and protection of live systems from contamination or unauthorized interference. 10.3 Reburn repeat failure control. Any reburn or repeat validation failure requires a root cause analysis, technical verification, evaluation of contributing factors, including rushed work or fatigue, and leadership approval before rework. 11. Root cause control, fiber and copper validation failures. 11.1 Overview. In hyperscale environments, validation failures typically result from physical infrastructure issues, including dirty or loose connectors, poor splicing, installation errors, hardware optics instability, software or firmware inconsistencies, inadequate training, environmental heat, and poor team coordination. Estimated distribution of failure causes may vary. 1. Dirty, loose connectors, 30 to 45%. 2. Bad splicing, 30 to 50%. 3. Installation handling errors, 10 to 25%. 4. Hardware optics issues, 10 to 25%. 5. Firmware software concerns, 5 to 10%. This illustrates that most failures are preventable through improved discipline, inspections, training, and QA and QC controls. 12. Fiber installation, standards 12.1. Labeling, fiber cables must be labeled in accordance with approved documentation prior to installation. Common failures include, may vary. 1. Incorrect rack labels. 2. Wrong elevation identifiers. 3. Incorrect port assignments. 4. Misidentified trunk cables. 5. Missing or damaged labels. 6. These labeling errors can lead to mapping discrepancies and validation failures. 12.2 Routing. Fiber shall only be routed along approved pathways. Improper routing may vary. 1. Misuse of pathways. 2. Inadequate strain relief. 3. Excessive cable tension. 4. Bend radius violations. 5. Improper dressing practices. These lapses may heighten attenuation and trigger long-term reliability concerns. 12.3 Fiber drops and rack entry. Fiber trunk lines must terminate in designated portals and patch panels. Common issues include, may vary. 1. Connection into adjacent racks. 2. Entry at incorrect portal locations. 3. Improper groupings within rack entries. Such mistakes can significantly affect validation success and network mapping integrity. 13. Splicing quality standards. Splicing quality critically influences validation outcomes. Common splicing defects may vary. 1. Inadequate cleaning before splicing. 2. Static contamination during preparation. 3. Incorrect fusion splice settings. 4. Damaged fibers. 5. Poor ribbon alignment. 6. Insufficient post-splice verification. Mandatory splicing controls. 1. Proper cleaning prior to every splice. 2. Approved fusion parameters. 3. Splice technicians must be trained and qualified. 4. Quality verification of splices before handoff is required. 5. QA reviews for critical workflows and areas prone to repeat failures. Splice work that fails quality standards shall be rejected and corrected before validation. 14. Connector handling and cleanliness standards. Connector contamination is a widespread failure cause and must be treated as a vital control point. Common connector problems may vary. Prevent validation failures by ensuring connectors are protected with dust caps when not in use and are free of dust contamination, oil residues, scratched end faces, loose connections, and dirty mating surfaces. Inspect and clean every connector with approved cleaning kits and fiber inspection scopes as needed before connection. Minimize direct handling of connector end faces and recognize that even minimal contamination can cause optical loss and validation failure. 15. Copper cabling control. Copper infrastructure is vital for network management and auxiliary pathways and must be handled with equal diligence as fiber. Copper scope includes: ensure Cat6, Cat7, Cat8 and other type. Management network, patch, equipment control, and management jumper cables are accurately labeled, properly terminated, correctly routed, protected from damage and contamination, tested before handoff, and maintained in an orderly, energized environment, as poor copper installation can result in validation failures and reduce system manageability. 16. Hardware optics and environmental control. 16.1. Hardware and optics. Some validations may fail due to, may vary. 1. Faulty optics. 2. Overheated optics components. 3. Firmware mismatches. 4. Intermittent hardware instability. 16.2. Environmental conditions. High-density network equipment. Configurations generate substantial heat loads. Contributing environmental factors include, may vary. 1. Elevated rack temperatures. 2. Cooling fluctuations. 3. Concentrated heat in specific rows. 4. Optics performance impacted by unstable thermal conditions. 16.3 Required controls. 1. Enhanced monitoring of cooling systems. 2. Awareness of optics temperatures. 3. Cross-checking hardware issues before repeating fiber rework. 4. Coordination between infrastructure, cooling, and validation teams. Environmental instability must be factored into troubleshooting to avoid misattributing failures as installation faults. We've reached the end of Part 2 of the Hyperscale Data Center Mega SOP. Continue to Part 3 in the next video, where we'll cover the next phase of the standard operating procedures and continue building the complete operational framework. Thank you for watching, and we'll see you in Part 3. For additional information, contact José-Alonso Hurtado González.